Hey everybody, quick announcement. I wanted to let you know that we are moving this and future podcasts that we might create to the new Keysight Podcast YouTube channel starting in March. Go check it out, Keysight Podcast YouTube channel. I'll see you over there.
Hi, and welcome to EEs Talk Tech. My name is Daniel Bogdanoff, and today we're going to talk about big data and test management and how you should go about analyzing that. So some trends behind what people are doing, what people are struggling with. So today, if you guys could introduce yourself and tell me kind of what you do at Keysight and what you're excited about to talk about today.
Sure. I'm Brad Dorr. I'm Director of R&D for Keysight's Oscilloscopes, Logic, and Protocol Analyzers group. We do a lot of hardware and a lot of software, and I'm interested in a lot of things. Today, I'm very interested in data analytics and want to share some of my thoughts on that.
Hi, everyone. My name is Eileen Grumbine. I'm the strategic planner for Internet Infrastructure Industry Solutions team with Keysight. And I worked for over 2 years now with Brad on data analytics. I'm very excited to talk about it today.
Awesome. So, if you're a hobbyist in your garage working on a microcontroller project or something, data analytics isn't necessarily a big project. But what we're seeing a lot, especially with some of the larger engineering companies and in Keysight ourselves, like you direct an R&D department, and our team is not just here in Colorado Springs. We're spread out all across the country, all across the world. So that presents some pretty significant challenges in terms of how we look at data, how we compile data, and make good engineering decisions off of that data. So could you expound on that a little more, Brad?
Sure. A couple of thoughts. You're right. We do have a giant engineering team at Keysight, and we have the same kind of test and measurement challenges that I think any modern engineering company has. And before we go there, though, I will say that for the hobbyist in the garage, potentially that person is generating a lot of data, but that person can handle that. It's a team of one. And so Tableau or Jump or an Excel pivot table or an Access database, you can develop things yourself. And it's important to start with the design of experiments. And then it's important to know how you're going to make those measurements, to make them. It's important to realize that your design of experiments is going to change over time, and hopefully whatever you created will be easy to morph. And for a team of one, that's a hard problem, but it can be handled by one. What I encounter is engineering teams and engineering managers, and I know, Eileen, you've been to countless engineering firms, and the medium and big size companies, they really generate a lot of data. They have multiple projects going on in parallel. These are giant systems intended to work in a wide range of conditions. And so they make a lot of prototypes, and they do a lot of testing to make sure their specs all match and that they know how it performs. They know if they need to recut the prototype for $1 million, for example. So they generate a ton of data. And managing that data well, I think, we've seen some of the best and some of the not so best. And the best manage that data well, and they make confident decisions, and they get to market faster. And the not so best, they go slower, and they're not certain about their results. They struggle sometimes to find old data, to incorporate data from multiple sources. These are the things we see. We're talking terabytes of data for sure.
Yeah. Eileen, anything to add to that?
Yeah, I mean, for example, Brad and I have met with this engineer who said that a lot of his time is spent on data massaging. He should be doing analysis work, finding out what's the root cause of his the failure of his devices. And if he can pawn off this work to his technician, to collect all the data, make sure that they're in place and make sure they're complete, make sure they're in the right format, and then he can focus all his work on doing analysis work. And then I think that's what's important, when you work with multiple sites. Everybody has their own format, everybody has their own measurement technique, their own DOE, and it doesn't necessarily talk to each other.
Another part of that same story she's talking about, we had a manager tell us, and we've heard this in different forms, where they had lost confidence in the data they had stored on some file share system. And they weren't exactly sure what conditions it was made and if they had it all, for instance. And one of the guys said to us, I'll never forget this, I know you remember this as well, said, I would rather remake the measurements because I just don't trust the data, whether we have it all, whether it's accurate, whether we know the conditions. And that's an extremely expensive decision. It's a reminder that if we if we get organized up front with our data analytics, with our data archival, then we can actually leverage that data. Otherwise, it creates doubt.
It totally makes sense. I remember playing around with our tool a little bit and seeing something about how you could look at how measurements trend based on the user. So, I thought that was pretty interesting. So, maybe the lab in Japan is getting slightly skewed measurements and being able to kind of back that out and figure out where that's coming from. And if I'm getting different measurements consistently than the guy in Japan, and I can statistically show it, that seems like something that would be pretty easy to backtrack out. So like, is it my equipment calibration? Is it my lab temperature? Is it like a EMI environment? Is something else going on there? And then being able to actually quantify the difference when you go and try and tweak that, I think seems pretty useful.
I think it really is. One of the things we always coach our, the engineers and the managers we engage is to start up front separating the properties from the measurements. Another way to look at that is metadata from the data. Once you've got those separated, and if you archive those in that way, then your independent variables and your dependent variable can be managed, and you get your maximum analytics. So I manage a large lab of engineers. We have many projects going on in parallel. Keysight itself has, thousands of products, and we have a huge manufacturing operation. And being able to separate production line A, B, C, or product or test bench or manufacturing station XYZ. That's an example for manufacturing. For prototypes, the same problem exists. We have groups of technicians. Maybe one technician doesn't follow the procedure exactly right or has the newer version of the procedure. And then if you have that data orthogonalized, if you will, then you can quickly dig down to the answer. And it would be great to do that with Jump. I love Jump. Jump is awesome. The problem is Jump is a one-person workstation. And we have, as you know, Keysight has multiple stations. Most of the companies we deal with have global operations and need to have all those folks involved.
Right.
Yeah, makes a ton of sense. So another, could you give me, I guess, a couple of situations? I know this is a tool that we use internally. Can you give a little insight into how it's helped us get our stuff out the door? Or make go, no-go decisions, that type of thing?
Sure.
And I know our software architect's not here, the guy who kind of, spearheaded this thing. But
well, you only have 2 seats here. If you had 3 seats, he would be here.
I know, we'd have Mike too. Sorry, Mike. Yeah.
But to answer your question, we use it just like anybody else would. Keysight's, at the end of the day, we're building electronic and optical equipment. It happens to be that we make measurement equipment, but just like any other engineers we work with, the same thing, where we're looking at conditions like temperature, voltage, software version, ASIC tape release version, even like contract manufacturer. Sometimes we'll have one printed circuit board vendor and we'll swap to another. We'll want to compare the data. And to be able to look at scalar and, I like to use the word vector, but let's call it array data, scalar array data. And lots of, test and measurement has its own special kinds of data, like constellation diagrams for 5G networking, spectral plots for RF or electronic warfare, et cetera. All of these are very different. And in fact, I had an engineer on my team the other day, a senior engineer, come to me and say, why can't I overlay my spectral plots and my phase plots and then filter out the ones that happened in high temperature or filter out the ones that had that bad software release and see what results I'm really getting. And then I can make a snapshot of that, send it to my boss and say, my design is done. And those are the kind of problems we see, but it's exactly the problems that, in the customer visits you've been to recently, I think it matches. Right.
I think one use model I'll add is the simulation one. I think a lot of engineers now you do simulation before they actually go on tape release. So the data analytics software can help you, figure out whether your simulation data is good enough for tape release. Like if you're nearing the fail limit, if you have enough margin in your design, those are all important information before you make any decision on the tape release of a chip. Because it can be expensive, you have to recut them.
Oh yeah. Yeah, no one wants to tape out twice, that's for sure. So that's pretty fascinating to be able to, massage based on metadata. What I hear, and I'm going to throw a curveball at you, when I'm listening to this, I'm like, oh man, trying to set that up sounds like a nightmare. Like, can you go into what it takes to get that kind of data set in the first place?
Yeah, I think in all the engineering teams we've been meeting with over the last, let's just bound it to 2 years. These are giant projects. These are teams of 5, 10, 15, 20 IT engineers helping out engineering teams to build the infrastructure. And that's great. The problem is that's expensive. You can imagine the loaded cost to a company of 10 IT engineers.
To manage data.
To manage data. And these are big programs. These are programs where you want to have automated test environment, and then you want to have some kind of repository to store the data. The problem is that if it's not architected in a forward-looking fashion, you end up getting a custom, big, expensive solution for your Wi-Fi project you're on this year. And then as your team moves on to a DDR4 project or PCI Express Gen 5 project the next year, your IT team has to rework all of that stuff. And so the analytic solution that a smart engineering company would go after is one that is data and domain agnostic and flexible. And also, it should be a package that you hand to your IT team and say, install this baby, and your whole team can have a web interface, and your Singapore team and your San Jose team, et cetera, can work seamlessly together and not have to become an expert at Tableau or Jump or Access database, stuff like that.
Yeah, that makes sense. And I think you mentioned seeing in a lot of teams, there's kind of one individual that gets really excited about this. How well is that individual typically doing at managing their team's data?
I think it's tough. When you assign an electrical engineer to be an IT person, that's tough. Some of them do a great job. We know a few names, and we're not going to mention names of engineers we work with.
Don't.
But they do a great job. But on the other hand,
well, you can say if they're doing a great job.
A lot of times, those are the team lead, the architect, or someone who is the only one who knows how the optical interface works. And that person is 50%, let's say, buried in data. We had one executive tell us, I can't even hold my project meetings if so-and-so doesn't attend, because that's the only person who knows how to use the pivot table thing that he created, and also the only person who knows where we stored the data, and we wouldn't have confidence to make decisions. It's a bad investment to have electrical engineers doing IT, I think.
Right. I mean, pivot table is easy, but for a new user, like even an engineer myself, it's very hard to maneuver around the Excel spreadsheet and creating pivot table that will give you that custom look that you want.
Yeah.
Just for reporting.
I think big companies need an enterprise class application that is manageable by their IT team, but is not custom, and that allows them to jump from project to project. That's what Keysight does. We're currently releasing 10, 15, 20 new products this quarter, and we have engineering teams going from project A to project B, and it needs to flow seamlessly. And we shouldn't have our electrical engineers or computer science guys being buried in that kind of IT stuff.
Right.
Yeah, I know dealing with other people's pivot tables keeps me up at night sometimes. I just don't even want to go there. So having something that's useful for a full team, I think, is really, really valuable.
Yeah, web-enabled. I want to be able to see the Singapore results at 8 a.m. when I roll into the office.
Yeah, not when they're in bed
or their quarterly report. I don't want to wait for their quarterly report to know if they have a major problem. I need to know that on Monday morning.
Yeah, makes sense. Interesting. Can you talk a little bit? I know one of the things that you guys get to do is you get to go to plugfests and that type of thing. Can you give a brief overview of plugfests and kind of how that ties in with?
Yeah, a lot of these high-speed serial standards, they have workshops and plugfests where everybody gather, all the people in the industry who does the same design, gather to make, to test their product to make sure that they're, interoperable with other systems, and that's where there is a lot of activity going on, and there is a lot of data being collected, and that's what what we have fun doing is to get to look at all these test results and look at how every person in this in the industry is performing, and we see the value. A lot of let's say the peers in the industry would like to know how their device perform. When it's compared against the other peers in the industry, and
because they're kind of like this convention of frenemies, right?
Right,
Like
yes.
they all kind of know each other and get dinner together, but then
USB there is a hub. It might not be competing, but there is a hub that performs this way, versus the other way, and then there is also the USB thumb drive people. Although they don't design the same thing, but they work. There's a collaboration there, I think.
Yeah, and we see people coming in with like their device in a cardboard box with one little port sticking out so that no one can see their circuitry and what's going on. So one of the things that we get some unique access to as Keysight is we get that collection of data.
Yes, we do. And one of the things that we plan to do is, let the other designers in the industry have a way to observe those data. They may not want to necessarily compete, but they want to know where they perform before they go into the next plugfest. If they are way out there compared to the rest of the peers in the industry, they might want to redesign or rethink. Because going to these plugfests are not cheap, so it's a way for them to cut their costs. And also their design cycles.
For sure. So with the Keysight tool, you can actually see how your data stacks up to the industry standard. Of course, we don't release company info.
Oh no, we don't do that.
Obfuscated, but that's a pretty useful thing too, especially for some of the specs that roll out to the mass market and maybe lower performing specs to see for USB 2.0, if I have a USB 2.0 device, how does it line up to the rest of the USB 2.0 market?
Right.
And is it probably going to work or is it not? Because we all know that there's sometimes flash drive works and some of them you just have trouble with.
Yeah, it may work, but it might be marginal, so
right.
that could be another issue.
Daniel, on the other end of the spectrum, at the beginning of the design cycle, especially for large designs, a new ASIC or a whole new system, there's a lot of simulation that goes on. And so at the very other end of the spectrum, at the very beginning, it's really important to be able to compare your design team's simulation results with your validation team's empirical, physical measurements.
That totally makes sense.
And so there's kind of three phases to this. Actually, there's four. There's design versus validation. And then there's, let's say, validation versus manufacturing data. And then there's also my data versus the industry data. And so there's a lot of different ways to use analytics. And if you prepare your design of experiments smartly up front, you'll have that. And you archive the data in a trustworthy repository, some kind of enterprise class application, then you have access to do all those comparisons. Otherwise, you're in the position that other executive was in, where he said he just has his team remake the measurement.
Right.
Take a month to remake all those measurements. That's bad business.
That's painful. Yeah, I can't imagine that happening in this building. That'd be rough.
Yeah.
So we are about 15, 18 minutes in. Are there any other closing type topics that you want to hit on data analytics?
I think we didn't cover manufacturing, but I would add that most of the people engineers that we have met, data analytics is a big factor in manufacturing.
Okay.
So not all the R&D tests get transferred into manufacturing floor because they already done a lot of data analytics and they already know that you can skip this test and hence you can cut your manufacturing cycles.
We do about 10% for our products. About 10% of our characterization tests make it into manufacturing because time is money when you're manufacturing thousands of units a month.
Yeah.
Yeah, and then the manufacturing actually they collect a different kind of set of data for analysis. They look at yield. They look at what are the failures, what OEM partners they have that causes this failure. So those are all the different kind of data analytics, but it's also important.
Yeah, totally. That makes a ton of sense. You'd mentioned earlier doing yield by manufacturing line or technician, that type of thing. I think has a lot of value also. Are you seeing people getting raises or getting fired based on data? Because it seems like at some point, if you're responsible for line 1 and someone else is responsible for line 3 and they're getting consistently better results.
We did have one executive tell us that that they had done a poor job of sharing all of their data in their homegrown analytics system. And their expert had said that they didn't see he didn't see any problem why they couldn't proceed to production, and she went ahead and authorized production of this, or fabrication of this. In this case, it was an integrated circuit, and if they had shared that data with the entire team, they would have found the fatal flaw. They ended up fabricating for about $1 million
Oh no!
A device that had to be redone, And that really cost them not just the $1 million for a tape release for a big digital ASIC, but also you can figure this is at least 6 months of time to market.
That's brutal.
Yeah, so that's an example anyways.
Excuse me. Interesting. So you guys are presenting a paper at DesignCon next week. So today is late January, and we're filming. I don't remember what day it is. It's Friday. Is there anything you're excited about for DesignCon? I've actually not made it out to DesignCon yet in all my years at Keysight.
DesignCon is always exciting and really chaotic in a good way. The thing that makes me most excited for having this discussion about analytics, one of the most common first questions, I'd like to know what the most common first question you get. The most common first question I get is, I love JUMP. JUMP is awesome. It has so many analytics capability. Why would Keysight create a test and measurement analytics solution? And why would anybody do that? Why would a company roll their own, create their own analytics solution? And the answer to that, there's a number of points. I won't go into it right now, but that answer is really insightful when you're running, especially a medium to large size company.
Okay.
Yeah, it's about the same. How is this different than my current analytics tool that I develop, using my own test skills, So I think that's the same one, and we know why.
Yeah, when you see an eye diagrams, superimposed eye diagrams or superimposed constellation diagrams, spectral plots, magnitude or phase versus frequency plots, and then you can do full filtering, and then you can export it to some other tool, for instance, MATLAB. That's where the answer starts to come in.
That makes sense. Awesome. So I imagine papers for DesignCon are probably public.
Yes.
So when this airs, the paper will be public. So you should go check it out. We'll try and put a URL down in the description.
Right.
And sometimes they do video too. I don't know if they'll have a video you guys presenting or not.
I think they are.
I know we've seen Jenny do DDR.
Yes, there's going to be a video recorder.
Okay.
And of course, we have the booth, for live demo.
Right.
So. Keysight Education Forum is where the videos will be stored.
Okay. So if you have a time machine, you can go back in time and go see them at DesignCon. One of the things we like to do on this podcast is at the very end, we ask a stupid question of our guests. So I'm going to make you both answer. What is your favorite metadata tag and why?
Oh, man. I'm going to have to copy your answer. Go ahead.
Well, I'll give you an answer that's my least favorite.
Okay,
I met with a group of engineers, and they had taken. They really didn't appreciate the importance of separating. To isolate their metadata, their properties from their measurements, and they had combined. I can't remember exactly what it was, but like communication channel with bandwidth or antenna number. That's what it was. Two things that shouldn't have been married together. And then they were like, well, now we'd like to split and filter this data on that property. And so we take a look at their data, and it's like, well, you merge those two things together. And so we had to write a script to separate those.
Sure.
It reminded me that people are really smart, and yet sometimes we do really dumb things. And we really need to think about how to separate temperature from workstation, from username, from software version. And
it comes back, I think, to whoever's managing the data. So there's one data guy who will probably do something, but then the other 90% of the team's like, just throw it in there and it's someone else's problem. Right.
And Keysight has made this same mistake before, I'll admit, and I was part of it, but we're getting smarter.
Yeah.
Okay, fair enough.
I think my favorite is temperature. Temperature, because like in the automotive industry, it's all about temperature. Your car can't run just on a hot day. It has to run in the snow. When it's below 0 degrees.
That makes sense.
So I think that's a very interesting test case, I guess.
Yep.
Awesome. Great. Well, thank you, Brad and Eiley. Thank you so much for coming on. That's it for today's episode of EEs Talk Tech. Make sure you subscribe to EEs Talk Tech in your favorite podcast engine. You can also go to eestalktech.com for show notes, get an update straight from that website. All we need is your email, and I don't think it even goes into our list or anything, so you can just get an update straight when we post the new one. And of course, subscribe to the new Keysight Labs YouTube channel. We changed it from Keysight Oscilloscopes. Wave 2018, also March 1st, that's coming up. Make sure, if you haven't already, go sign up at wave.keysight.com. We're giving away a ton of test gear. It should be a really fun couple weeks. And that's it for today. I'm Daniel Bogdanoff, Brad Dorr, and I. Lee Grumbine. Thank you for watching, and we'll see you next time. Awesome.
Cool.
Thank you guys.
All right.
25 minutes.
Nice job, Daniel.
Told you it was quick.
Thank you.
Man, you ought to be a radio DJ.
I have my own radio show. It's called EEs Talk Tech.